Hello and welcome to another episode of Q&AI. I'm Bob Friday, and we have the special honor to have Richard Socher here, who is an industry-leading AI expert and the co-founder of two companies, MetaMind and U.com. Welcome, Richard. It is a true honor to have you here.
Thanks for having me.
Your background is amazing. Maybe you give the audience a little bit, how did you end up from Germany, to being the co-founder of two AI companies?
Yeah, I originally came from Germany for my PhD at Stanford and worked on neural networks for natural language processing and computer vision. It was pretty broad at the time because it was a very nascent field. Pushed a lot of that forward and then started a company called MetaMind. We eventually got acquired by Salesforce, where I became chief scientist and eventually executive vice president, running most of the AI efforts there. And then in 2020 started U.com, because in 2018 we had invented prompt engineering, a paper cited by the early GPT papers from OpenAI. And in 2021 I also started a venture fund to kind of structure my angel investing a little bit better. And that fund has done phenomenal things and was co-founded with several other amazing people. And that's where we're at today.
And so what year, PhD, what year was this now?
I started in 2009 and graduated in 2014.
Okay, so this was the very early days of natural language processing. And I'm always interested in the origin story of the startup. So you're doing your PhD, and somewhere along the ways you had the vision that, MetaMind, that you were going to go start this company from scratch. Scary jumping off the cliff, or?
It was. I had actually worked for almost a decade at that point to get a coveted faculty position in one of the top 10 universities and ended up getting it. And then I had a couple of VCs, namely Khosla Ventures, say, hey, I'm going to give you some funding. Don't you want to take some of this research that at the time already had many thousands of citations and make it into a startup? And I thought, maybe I'll try it for a year and then I'll probably still become faculty. And then, during that year, I both was allowed to teach at Stanford and we're still doing some interesting research at MetaMind. And so I ended up realizing maybe I can do the teaching on the side 1 quarter a year, do still some research in industry, and also start shipping these as real products to real users and have that immediate impact versus the long-term impact and research that research can have. And so I ended up not taking my faculty job.
Okay, so you were faced at, going down the academic path, the professor, tenured professor, or really jumping into this industrial startup adventure.
That's right.
So the original vision for MetaMind, or what was how did you really engage with the customers back then, or how did you come up with the purpose of MetaMind? Yeah,
it was such a different world back then. You had to explain why AI might be useful and what classification is and why it'd be great to just drag and drop some images or text documents into the browser and get some knowledge about them back. And we had a first paper in 2016 called Ask Me Anything. It's a paper that had attention mechanisms, that had the ability to ask all kinds of different questions to one large neural network. And that eventually we pushed that even further with more complex questions in 2018 after the acquisition and at Salesforce. But we're doing all kinds of interesting research and trying to explain that to users, and most of them had no idea what a neural network is and whether that matters to their companies or not. Now, of course, it's a completely different world.
Okay, so this is the early days of transformers and attention is all you need. How big were these models you were playing with? Was it the size that kind of held you back, or?
Definitely, yeah. The size was definitely a problem. Also, the reason that transformer paper is called Attention is All You Need is that they showed that you don't need a recurrent layer, and it's a different kind of neural network that is much harder to train on GPUs. And so it was just slower in many different ways. It required more engineering to really scale up. And so we had a lot of attention mechanisms, but we still all made the mistake of thinking we needed that recurrent layer to keep very long context. And the transformer paper is beautiful, and it has this quadratic blow up, but you can see how, even with quadratic sort of complexity in the input size, you can do amazing things with transformers.
Okay, so 2018, kind of in the very early days of attention and transformers trying to sort out how to solve this problem.
Yeah.
And somewhere along the way you decided to, which is always another big part of the startup adventure, to sell the company.
Oh, sorry, yeah. We sold the company already in 2016. So this was all like from 2016 to 2020, I was at Salesforce already. Yeah.
But I'm always interested in what made you sell. So you were 2 years into the adventure,
Yeah.
and you decided it was better to stay at the plate or sell.
Yeah, it was like kind of interesting because we had built so much powerful platform technology, and then we realized that because the world wasn't quite ready yet for all these different use cases, you had to go very, very deep into one vertical to just start selling it. We didn't unfortunately have sort of the funding abilities to just keep on doing interesting research and build more and more large general tools. So that was always the hope. That was why it was called MetaMind. It's going to be this general purpose platform. But fundraising back then for AI and with our team, we just couldn't do what like OpenAI, for instance, was able to do, where they build robotic hands and they play Dota games. And after each of these projects, they're able to raise a couple $100 million more. That wasn't the case for us in 2015, 2016. And then also we realized that the technology is so powerful in the hands of a company that has, no pun intended, a strong enough sales force to actually explain this and bring it into enterprise use cases. And so there's just a lot of synergy, and Mark has been a phenomenal mentor and friend and investor of mine, and so it just was a natural fit.
Okay, so you kind of realized you're a little ahead of the market, and it was going to take a lot more money to stay at the plate.
Yeah.
So you went to Salesforce, and I think I went through that same experience. I sold a company to Cisco.
Yeah.
Small company. Salesforce was your first big company adventure?
It was, yeah. I mean, I was an intern at Siemens Corporate Research and Siemens before, back in Germany and Princeton, New Jersey. But yeah, it was my first sort of full-time job.
And, big company culture, like you, I've worked in both of these. They are slightly different. Yeah. Any words of wisdom of people making the transition for small startup experience to big company experience?
Yeah, I think a lot of people assumed it was bad to work in a big company coming from a small startup, but I actually had a phenomenal time. Yeah. I think a lot of very smart, very kind, hardworking people at Salesforce, and a lot of people say, oh, they just assume the bigger the company, the more politics there are. And on the one hand, I'd say, well, you put 3 people in the room, and you're going to get 4 different opinions, like on anything, right? And so I think that is also true at Salesforce, but ultimately, what the right thing is, just people differ, and you have to learn how to navigate the organization, understand who the real decision makers are behind the scenes, and then just see how you can have the most amount of impact on it, which I enjoyed it a lot. We had built out an amazing research team, and we could have a lot of freedom in that pure research world. We published a ton of papers. We invented prompt engineering. We built the first large language model for protein generation. So not just understanding the folding of a protein, but create completely new kinds of proteins. In biology, we had one paper that still hasn't really had its time in the sun, which was an AI economist. So it was a reinforcement learning problem where you had an AI economist and you had a bunch of intelligent agents that would interact in this economy and buy products and get resources and build houses and can trade and get taxed. And then you basically said, overall, the system should maximize productivity multiplied with equality. And then you could basically build, billions or millions and millions of years of taxation, test them out, and see what kind of tax structures and subsidy structures would create the best outcomes. That paper was like small, like just a couple dozen agents. If that kind of work could have, the hundreds of millions of dollars that we see for LLMs, we could actually much more realistically simulate economies and then find out what are the best taxation and subsidization.
So this is like the early agentic AI. You were working.
That's right. Yeah, that was in 2017 and 18. We already published that.
Okay, so you're already using, but you weren't using foundational large language models. You were probably using smaller models.
Large. We train actually a lot of large language models, but not as large as they are now. Yeah. Okay. We had the best language models. Stephen Merity and I published several papers where we really nudged language modeling forward as a task, but we unfortunately didn't train them as large as OpenAI did.
Okay, so back then, billions of weights. What were we at? 2018?
Like hundreds of millions of weights.
Hundreds of millions of weight. Because right now we're at what, 500 billion or something.
That's the really large ones. You can get pretty good results with 7 billion or so. But yeah, the really cutting edge models are several hundreds of billions. Yeah.
Okay, so it sounds like you're at Salesforce having some fun. you're doing
shipping real products, doing research. Yeah, it was fun.
Okay, so the whole professorship thing was in the rearview mirror.
I was teaching at that point for like 3-4 years at Stanford, and the class kind of blew up to like 600 students, and it was a lot of work. Eventually, I was like, when I first taught the class, no one in the world was teaching neural networks for NLP, like anywhere. And there was still an official NLP class that my advisor taught, Chris Manning, one of my 2 advisors, and I was teaching sort of the neural nets with NLP class, like on the side.
Okay.
And after 2 years, those 2 classes were merged because all the best models were becoming neural network based. And then after 4 years, it was, I think that quarter, 600 plus students, the most popular class at Stanford. And then it was a little bit too much work. And then everywhere in the world you could take neural net for NLP classes. So I figured it was less impact.
So I take it if I look under all at Salesforce, Einstein, Agentic, somewhere.
Yeah, we started the whole Einstein thing.
I'll find you under there, underneath the hood. That's all your work, I take it.
Yeah, it was a lot of fun at the Dreamforce. We introduced Einstein. Yeah.
Right. So now somewhere along the way you got your first agents going, and somewhere U.com. Was U.com kind of like MetaMind version 2, or is it something new?
It definitely started as something different, right? And so in 2018, we had invented prompt engineering. And prompt engineering back then didn't look like what prompt engineering looks like right now. It was much simpler. It's just the idea that instead of pre-training just word vectors or just an encoder, you want to pre-train the whole system. And to pre-train the whole system, the main idea was you have to make the task, the question you have for that piece of text, as part of the input. Okay. And so that paper in 2018 that I co-published together with Brian McCann and Tsai Ming and others was the idea that you can ask one model all kinds of different questions in NLP, and you get an answer no matter what. You can ask, what's the translation of this sentence into French? What's the summary of this paragraph? Who is the president of Ukraine that is mentioned somewhere in this document? And all these different kinds of questions. What's the sentiment of this tweet? And like all of these would just be inputs to one model together with some context, and out comes an answer. And that paper was also very famously rejected. I talked about this in a TED Talk, because for reviewers at the time, it was just unfathomable that you can have one model that does all of these things, because there are like thousands of PhDs and professors who have worked on just one of those tasks for years. To just be downgraded to like, oh, there's just one more question you ask to that one model, was just very unpopular at the time. But it did inspire a few other folks. Like,
there's a theme here. I can see you're a little ahead of your time here. I've learned with startups, right? You got to make sure you're not too far ahead of the market.
You're absolutely right. The biggest transition from academic to startup founders, like if an academic, you're ahead of your time, you're a visionary. Yeah. If in a startup you're ahead of your time, your company might just be dead. And so you need to be at the right time, right? And so now we have a strong sales team, and we've built agents before before they're sort of very popular now. That's why our platform, our customers have already built over 90,000 agents to automate workflow processes on U.com. But we're not, we're like several years ahead. So it's been working out really well in recent quarters.
Yeah, maybe for the audience here, that's a good point. You want to give a description of U.com, the mission here is relative to, I know Perplexity is out there, and there's a whole bunch of different.
Yeah, a lot of copycats out there now, yeah. So we were the first to connect a search engine that we already had and had been building for a few years to large language models, so that those large language models had citations, they had accurate answers, and they could be up to date. No one can train an LLM every 5 minutes something happens, right? You have to have that search index, and that search layer, a lot of people underappreciate that, how important that is. And so we're now selling as a company both seat licenses. You just go to u.com via u.com and you sign up, and we have over 50% of all Fortune 500s have paying accounts on u.com already, with millions of users. But we're now more and more focused also on our sales team, helping companies in the enterprise context, searching over all internal data and web data and merging those both as APIs as well as a UI on u.com.
And so are you chasing more of the enterprise space or more of the consumer?
We're fully enterprise.
Fully enterprise space.
Yeah, we're not focused. We realize that the consumer space is going to be dominated by Google. Most normal consumers don't have complex enough questions every day that they have a big need to switch. Right? If you ask like in your average week, oh, what's the weather tomorrow? What's like, is it gonna rain? What's the score of the game? Like, who's the president of France? Like, what's the price of the stock? Okay. If those are your 5 questions that week, you don't really need to switch from Google, right? But if you're a knowledge worker who has really complex needs, you're going to want to use u.com because we're actually accurate.
Okay,
we're
so
up to
you're
date.
focused on enterprise documents, specialized documents, right? I need your help to help me make that document more accessible or make that knowledge.
Document or that
knowledge.
entire database of petabytes of documents that are inside your company. Like we work with the largest press agency in Europe, the DPA, a German press agency. We work with insurance companies, we work with hedge funds. We also work with other consumer companies that have hundreds of millions or billions of users to provide them with our APIs to get search results on the web and on news and other things, as well as full LLM answers.
So you think the big guys, Google and Meta, they're going to win the consumer business? You don't think the little startups are going to challenge those guys?
I mean, already now you see a lot of the sort of challengers to Google sort of reducing in traffic, and it's very hard to monetize, right? You have like an early adopter crowd, but then normal folks are seeing more and more AI answers also on Google for the consumer space. I think the killer app for this is enterprise productivity. That's where understanding a lot of different types of context, bringing together lots of different types of information and document sources and data lakes and so on, all into one place, then help you automate certain workflows with really good answers. That's the best use case for LLMs.
Yeah. So the other thought our audience is really looking, since we have you here, it's not very awesome. We have like an industry-leading world global AI researcher here. Is this agentic AI? When I've talked to a lot of my enterprise customers, they're like, what is the difference between, how do I know this is agentic AI? Now, I've looked at Andrew Ng's definition, so I'd be interested, agentic AI, what's your definition of agentic AI?
Yeah, so agentic AI is generally AI that can take actions. If you look one level lower, these are all the exciting models today are neural sequence models. They're large neural networks for which you have large training sets that consist of lots of sequences. And whether that sequence is a list of amino acids and proteins for biology, it's a sequence of notes for music, it's a sequence of programming tokens in Python or English language tokens for something like ChatGPT and u.com. It doesn't really matter to these models what kind of sequence it is. And if that sequence includes the ability to take actions, like click on this button, then fill out this form with this text, given this sequence. If you have enough of those kinds of sequences, then you can train these models also either in environments or with feedback from humans to basically take those actions for people. And now I would differentiate between knowledge agents and action agents. Just a definition I came up with to show part of what's reality right now and what will come very soon. Knowledge agents are here. We have, like I said, over 90,000 agents created on u.com by our customers. And these knowledge agents will also take certain kinds of actions, like they say, oh, I should make a search here on the internet and get more information. Or maybe I should program code here and then even run that code to get you the real numbers, not like a bunch of fake statistics or fake numbers that the LLM might hallucinate, but real numbers based on your CSV files or your database or something like that, right? So those are knowledge agents, and they work and they're here. And they're already, we have beautiful customer quotes of folks saying, work that used to take me days now takes me hours. Work that used to take me hours now takes me minutes. And so that is a reality. Now the action agents that take irreversible actions, like booking a flight and so on, a lot of times they're just a little bit ahead of their time. They're not quite ready yet for prime time. In many cases, because you haven't seen enough sequences for training. On the internet, we can download billions and billions of sequences of English text. And so we get very, very good at producing and understanding English text.
Okay.
We don't have billions and billions of sequences of people saying, oh, I click on Expedia.com, then I click on these buttons, and then I click on this and this drop-down menu, and then I do this, and then I think a little bit, and I check my email and my calendar, and then I verify if my flight, if I catch this, and so on. And so because you don't have enough sequences, it's harder to automate these tasks as well as it is to do knowledge tasks.
Now, when I've looked at these agents, it looks like they all have something in common. That's like, there's a prompt with context, and there's some large language model that is consuming that prompt either to do knowledge or action.
Yeah.
Is that the right kind of high-level description of what an agent looks like?
Yeah. A lot of agents, you need to prompt them well, and then these agents are often getting access to tools also. In our case, tools are like searching the web, writing code, executing that code. And in the future, both in U.com and I'm sure many other places, you'll have even more actions. Now there's even a whole protocol, maybe relevant also for sort of networking nerds, is like protocols like the MCP model context protocol, where these agents can more easily access other tools that can help them do certain things like book a flight or something like that. And they have very specific ways to communicate, and that makes them even more powerful.
Yeah. Now, does each agent in your mind have its own specialized trained LLM, or are they using a generic, there's kind of what I call large foundational LLMs to solve problems, and then you have these smaller specialized language models to solve different problems?
Yeah, so a lot of times you just use one general purpose large language model as the base model for an agent, and then you give that agent in the prompt access to certain tools and instructions on what it should do, and then the neural sequence model will produce English tokens and from time to time action tokens. And so the big difference is that the prompt needs to really include that possibility of taking those actions. And then, of course, the system around the LM. A lot of times people think about an LM as like the whole thing, but you can more correctly think of the LM as kind of like the CPU on the motherboard. And there still needs to be some RAM, which is kind of the context that you put into the prompt. You still need a hard drive, which is retrieval augmented generation over your entire database and stuff that we do at U.com a lot of. Still need an Ethernet connection where it connects to the internet and you get information from the web. Like all of these things need to be connected to that CPU center that is the LLM.
Yeah. Now, I often describe people this Agentic AI as kind of a new software programming paradigm. It's nonlinear, non-deterministic. We're dealing with large language models. It's nonlinear because it looks like people are connecting these agents in graphs that are not totally predictable how they're going to work the way the graph. Where do you see us in the journey of leveraging, Agentic AI? I think is, what do you think, a year old? How old do you think Agentic AI is right now?
Yeah, depending on how you define it, we've had at Salesforce, even in 2017, 2018, we had the first agents that could pick up a phone and have a conversation with an agent, and it would give you answers and will do certain things and find a replacement package and stuff like that. So agents go way back, but thanks to large language models, they've just become much more general. And now actually you have to restrict them back. Like sometimes people, you ask like your agent for a car mechanic to write you a Python script, and it's so general purpose. It's a general purpose LM, so it'll write you a Python script. But then it's like, should a car shop really write you Python scripts because it actually is like overhired? So I think there's sort of three stages in generative AI. One is just like simple co-pilots, like autocomplete, like it'll do a little bit of work that would have taken you a few more minutes, down to seconds. Now we're in the second phase already, starting to get into where you take more longer workflows and you give them to an AI. Things that would have taken you hours now takes a few minutes. And we see this with ARI, our advanced research agent, for instance, on U.com, where it will take 5 to 10, maybe even 15 minutes, but then it writes you like a 20-page report. And it's like hiring a consultant. In fact, we have a lot of consultants who are our users. And then the third one, which we're not quite there yet, is when you actually really hand off entire tasks to an AI coworker, and then it will go out and maybe come back a few days later, but have done now the work of months. And to do that well, we have to learn to onboard these AI agents better. And like you said, they're sort of not deterministic. You're going to have to onboard them almost like people, right? Even if you take Einstein, one of the smartest people in the world or someone, and say, all right, now go answer all these emails, they have to be like, well, how do you want to answer this email? What are the option choices that I should consider? What are the trade-offs I should consider, and so on? So you need to onboard these agents more and more similarly to how you'd onboard a human.
Yeah. Now, here's a topic, because I'm going through this myself right now. It's like, it's one thing I'm dealing with public documents. I can pretty much send that data anywhere largely. When I start dealing with like enterprise customer data, where do you think the enterprises are? Do they trust you to send that data to Microsoft? They trust Microsoft for their email. Are they going to trust Microsoft, for OpenAI, ChatGPT? Or do you think those large language models need to be brought in-house or smaller versions of it?
So we, in particular, often deal with searching over the internet, and it's very hard to bring the entire internet in-house. All right. So for us, a lot of the queries that come to us they're staying with us. They're not, shared. There's no data sharing. There's no selling of your data the way you'd use when you use Google, and there's no advertising or any of that stuff. But it's hard to keep that within your own on-prem infrastructure, and so. That is a big part. And then, of course, you have to be SOC 2 compliant and think about single sign-on enterprise security and so on, which a lot of the players on the consumer space don't do as well, but we really focus. So we're allowed and able to work with hedge funds, insurance companies. The NIH just became a customer of review.com. So we have some very complex use cases where the accuracy of the answers really matters. You don't want to just have a rough hallucinated, maybe correct or maybe not correct answer.
And where do you think we're on the journey right now, enterprise trusting AI? I deal with a lot of customers right now, and I think they're okay with you, human in the loop, helping them gather knowledge back, but the action part seems to be the next phase of the adventure. I don't know if you've done the Waymo Uber self-driving thing. It's people are fine jumping in that Uber, and they trust it. I'm not sure why, but they trust it to get them from A to B. But they're still a little hesitant to let an AI assistant touch their network or take action in their own network.
Right. Yeah, it will take some time. I think people have to test but verify, and it's not helpful that there are a lot of sort of quick prototypes out there that look on the surface oh, that's like U.com. Why do I really need to pay for this? We actually have several customers who started having their own versions of a U.com interface internally in the company, because you just slap a web interface together and connect an OpenAI API. Right? It's not that hard. But then they realize it's 70% accurate, and you can cherry pick 5 examples and look, it's perfect. But then when you really use it, people don't have adoption, they don't know how to use it, they don't know how to prompt. So a big part of what we're doing at U.com for our bigger customers is we actually give role-specific training also to all their employees. And we've seen a huge amount of improvement in adoption of these tools after you do also AI-powered personalized training for each role. So in the beginning of that training, the user says, this is my role. I'm a VP of backend engineering or something, or I'm the CEO. And then the training actually becomes unique with examples for that role. And so that is one of many steps you need to take to get people comfortable over time. And eventually there's going to be a lot of co-adaptation. People are going to, just like when you use early speech recognition, right? You wouldn't just be just get me from here to there. You would just be directions to, and you try to speak very clearly. Yeah. That kind of co-adaptation of humans and AI, we're going through a major new phase of that. And kids that are growing up now, they're already kind of, learning how to scream at their Alexa or something to make stuff happen, and it's a little bit scary sometimes hearing them.
I kind of wonder, you guys, when we get into this new kind of nonlinear, non-deterministic software programming, is it going to take a whole new generation of programmers to get used to programming in this technique, right? Because I think you and I, we're used to linear programming. We bite a function, we write a unit test, and we're done.
We're also an investor in Windsurf and at AIX Ventures, and so we do think all of programming is going to be very different. We also invest in Marimo, which is a specific type of, I don't know if you know Jupyter Notebooks, where you can do programming for data scientists often. It's Jupyter Notebooks, but on steroids. You just your data gets loaded right away. You can spawn massive numbers of machines. You can get everything is just sort of done for you, and you just can focus on really important bits, and you just have much more efficiency and productivity. We're going to see more and more of that. I think right now, programming is getting better and better. I think if you're at or below average of a programmer and you do a lot of things that are quite repetitive but still need a little bit of thinking, AI can already massively 10x you. If you're one of the best programmers in your field, then maybe AI is not yet as good, but even then you just be just write unit tests for this remaining stuff, and there are things where AI, and in fact this is a general thing, any domain where you can verify and or simulate that domain, AI will dominate it and get eventually better than humans. And programming, you can verify, right? Similar to math. Math, you can allow the AI to explore a bunch of potential options, and then you can verify every step through it. And so eventually AI is going to write proofs that humans have not yet come up with.
Okay, Richard, are you a wine connoisseur?
No.
Okay, because I think this could be an all-day session over some wine tasting here.
Yeah.
But maybe to wrap up this episode, I mean, I think you were quoted as saying last year, 2024, that we were 5 years away from superhuman AI. So, any changes in your prediction, or how close are we to this general Terminator?
So I think there's AGI, and then we have to separate that out from superintelligence. So I think depending on how you define AGI, either already been there for a while, or we're going to get there in like 3 years or so. And that's there are lots of different ways, but you want to say basically that it's as general as a human. You can start onboarding it, and it will do many tasks for you with reasonable feedback back and forth, and generally be able to solve lots of different kinds of problems the way a human would. Then we have AGI. I think the next level, which me and a lot of other folks are thinking about now, is superintelligence, getting to have AI that is even better than not just one human, which is not that hard. Most humans can't translate 50 languages, right? And AI can. Just like a calculator could have done better multiplication than humans, and superhuman in that respect. But it's superhumanity. Like, it's better than all humans working together on a task. And I think we're gonna make an immense amount of progress towards that. I think just like with AI, the goalposts will continuously shift. Once we solve a problem, then it's just like, oh, that's just speech recognition. That's just like Siri on your phone. It's just a chess app on your phone. All of those used to be sort of the cutting edge. And if we get there, then we have real AI. That we'll see that moving goalpost several times with superintelligence too. But again, anything you can simulate, you can verify. Like, AI will make a huge amount of progress in the next few years.
Turing test? You think he wants to pass the Turing test yet?
The Turing test is already clearly won. Even before LMs, there are some cases where it was won sometimes. Now I think the Turing test is best won by reversing it. If you can ask questions that are so hard that a human couldn't do it, and that's how you know it's an AI. Like, hey, write me this Python script that does this really complex thing and sort a list and thinks about this RAM. And if 10 seconds later you have a perfect answer, you're like, that was not a human. The humans can't type that quickly.
We have to get the AI to look a little dumber, okay, guys?
Exactly. That's how much things have changed.
Okay, well, Richard, it's been a pleasure. I cannot tell you how much it's been a pleasure to have you
Thank
here
you.
today.
Thanks for having me.
And thank you everyone for joining us, and look forward to seeing you on the next episode of Q&AI.